Okay, you ready? Go.
What's the question?
Are we starting over?
Yeah.
That's what you thanks. Hello. This is for Algebra 3-4. But I guess Algebra 1-2 could also have it. This is Miss Muhs, and Chris is going to introduce himself.
Hi, I'm Chris Muhs. I'm Miss Muhs' husband. I'm an operations data analyst at TriMet. I've been at TriMet for 2 years. My job is to do a lot of the data analysis for the MAX vehicle maintenance department. And then I do some other data analysis for other transportation operations things at the agency.
Okay, so I'm going to ask you some basic questions about stats. So we look at normal distribution, z-scores, and then correlation and causation, and some bias. So can you just tell us if you use, or how you might come across normal distribution at your job?
Yeah, so a lot of the stuff that I deal with is normally distributed. So a lot of times I look at things like how long it takes mechanics to do certain tasks, or how long certain trips will take. So there's like a scheduled trip time, and then we'll look at how long they actually take, and usually it's all scattered around the scheduled time. Some are early, some are late. So yeah, a lot of stuff at TriMet in my job follows a normal distribution.
And then do you talk about z-scores?
In my work, we don't really talk about z-scores, but they are useful if you want to understand like how far one observation compares to like the rest of them. So basically, if you have one trip, let's say, that took a really long time, you can use a z-score to determine where it falls along the distribution of all the other trips to see how likely it is for a certain trip to be an outlier, or how far from the average it is.
So then what other data, or what other like methods of measurement do you use?
We use the mean and the median a lot. I like the median a lot for reporting stuff at work, because like if we go to the example of how long it takes to, let's say, change out the tires on a bus, you have some mechanics that do it really fast, some that maybe take a little bit more time, some that find other issues when they go to do it, so it takes them longer. So sometimes observations can get skewed by, like, if they find like a big problem with the axle on the bus when they go to swap out the tires, like then the tire change is going to take a long time. So when you have a really high value like that, it's going to skew the mean. It'll skew your average. So if you look at the median instead, it's a better measure of, well, we call it measure of central tendency. So the median is less influenced by really high values and really low values. So I tend to try and report on the median when I can.
So that's what we do in Algebra 1-2, actually.
Okay.
What about correlation and causation? Do you ever have to clarify, so this is a question from a math teacher. Do you ever have to clarify to your colleagues the differences?
Yeah, all the time, pretty much.
So like who are you then, so like if you're running a report, who are you having to explain it to?
Well, usually somebody asks for like a particular analysis, but a lot of times I have to explain stuff to like the executives at TriMet, so like the chief operating officer or the CEO, and they are usually quick to like make conclusions about what they see, and a lot of times they just want the explanation of why something happened, when in real life it's always more complicated than like a simple thing happened. So you usually have to remind like executives of, this looks related, but we can't say that this is causation.
Okay. So then another question or idea that came up was how COVID-19 has affected, like how has that changed the data for TriMet? Like what changes have you seen since March?
Oh, it changed everything. So, like with the maintenance work, they started doing disinfecting on the buses and the trains. So that's like a whole new set of data just on the special cleaning that they're doing that's coming in that people ask for reporting on. They cut back the service a ton, so like just the amount of bus lines and the amount of buses going out is way different now. What else do they do? The ridership decreased by like 70%. So we've been tracking the ridership every day, and
Would you track it before though?
not at the daily level because there's not enough samples basically. There's not enough samples on ridership to get accurate estimates every day. So they publish on the TriMet website. They publish monthly ridership, like the number of people riding the buses and the trains. Now we've a guy in my department has been publishing it daily and weekly, which is a new thing. But that's interesting because it's fewer samples, so the data is less reliable.
But how is it fewer samples if you're doing it every day? Wouldn't that be more samples?
Oh, I mean samples of the number of buses with passenger counters on them. So.
Don't they have like a clicker though sometimes?
No, it's an infrared sensor like above the doorway, and it just detects like an object coming on or going off. But we do some, we have like a statistical process that actually comes up with the ridership data that gets published. So you have, we're gonna go past algebra 3-4 here. You do what's called a Monte Carlo simulation, but basically you have a limited amount of data, but you can assume that the data you have is similar across all types of buses, and then you do a process that basically iterates and estimates the ridership across all the buses from just a subset of a few of the buses that have good passenger counters. Same thing for the trains.
Wow. Okay. Another question from a math teacher was, how do you, like, what influences you to change or edit lines? So, like, if you have to, so, like, for COVID-19, there's less buses, so how do you know which routes to cancel and which ones to keep?
So we keep track of ridership on every line. So every quarter is when the bus service and the rail service can change. And so every quarter the scheduling department looks at ridership by line, how much it costs to operate the line, how crowded the vehicles are during certain times of day, and through a combination of all those things, they decide to make changes to line by line.
Okay.
So it's basically driven by ridership and like utilization of a particular line.
So if there's less passengers, that's the one that's gonna get cut first.
Yeah, that's a simple way to think about it, yeah.
Okay. And then this is from Miss Seagraves. Why is the number 19 so infrequent?
So number 19 is actually not that bad.
What do you mean not that bad?
Number 19 in the morning commute hours, like from 7 a.m. to 10 a.m., the 19 towards Cleveland comes between every 12 and 15 minutes. So that's actually not that bad.
12 and 15 minutes? But if you missed the first bus, you're waiting.
Yeah, yep. And I did look into this. 19 does have a relatively high amount of really crowded buses in the morning hours. So it might be a good candidate for the scheduling department to increase service.
So if a passenger contacted TriMet, let's say when things were back to real life, would they have any influence in increasing?
Yes. Yeah. Yeah, there's a contact TriMet like form you can fill out online, and they are pretty good at taking input like that from the public and then relaying it to the scheduling department. So yeah, if you want more buses, say something.
I would like one bus
One bus.
from here to Cleveland.
Okay.
Did you take stats in high school? Do you remember?
No, I didn't have a dedicated stats class in high school.
Yeah, we don't either.
But I did take a lot of stats courses in college.
Did you have to take them or did you want to take them?
I had to take them, and then later in grad school, I don't know what happened, but I decided that I wanted to take more. And then I started to like stats a lot, and then the rest is history.
The rest is history. And then how did you use stats at your last job when you were working in consulting? Like in more engineering capacity.
Engineering is, at least the stuff that I was doing, is more about like upper limits. So it's like you have established thresholds that have been developed over time from like historical studies, and then like you need to just kind of make sure that whatever you're doing doesn't exceed like a safety limit.
Like for a bridge.
Yeah. Yeah, so like for buildings, for example, the structural engineering calculations on a building, like you base it off of how much stuff weighs and how much the weight that's going to be inside it, and like if not so much around here, but in the Northeast, like they calculate the snow load on the roof, calculate the wind loads like on the structure, and so you can do all these calculations, but then you multiply everything by 3. They call that a safety factor. So a safety factor of 3 means that most buildings, like per building code, are designed to withstand triple the amount of forces that they should really expect. So in engineering, you're usually designing something and then you're just making sure it doesn't exceed like whatever that limit is.
What's the most underrated thing in statistics, in your opinion?
The basics.
Which are?
Like, a lot of people don't understand what an average is, what a mean is. A lot of people don't know what a median means. A lot of people don't understand how the normal distribution works and what it implies. And just those things alone are really powerful.
What about, because I told you we weren't doing p-values.
Yeah. Well, p-values are related to z-scores. You said you're doing z-scores.
Mm-hmm.
So, like if you have a normal distribution, like the z-score and a p-value are like interlinked.
So do those come up at your job now as an analyst?
Yeah, like if I do any kind of modeling, like prediction, then you get an estimate of basically how accurate your model is, and then you use p-values to determine whether things are significant.
Significance.
Yeah. The z-scores and p-values are like, they're linked.
We got so much time though. Okay, any parting words?
Don't be afraid of stats. A lot of people don't like data and don't like stats, but it's not so bad. It's just numbers.
Some people don't like numbers though.
Yeah, that's okay.
So you would recommend everyone to take a stats class in college or for fun?
I mean, you're probably going to have to if you're going for a degree, but yeah, it's not so bad.
Okay, compelling.
Yeah, means and medians. If you know those, you're good.
All right, I should hope so.
You know how they work and what the...
What about standard deviation?
Yeah, that's important. that's a good one. Standard deviation, that tells you a lot. I mean, that's related to the normal distribution.
No, I know it is.
Yeah.
Okay, well, thanks for listening to the Mooses.
Anytime.
Welcome to our new podcast. Okay, bye.